Okay.
Okay. So recording started. We had about 10 minutes prior to this of just um, kind of catching up with everybody. Wanted to apologize for having to postpone a few weeks this month's talk, and I hope everybody can get on this at some point. Light load today, and I expected it because of that switch, that change of venue on timing at least. Um, so I was asked actually by Angela to do a talk on the eyes for dogs, and so I cogitate over what exactly to focus on because there's so much, we could go into the science of it and all that, which I will briefly. Always need a background on things. So, and of course, I'm kind of get into the science, the real science of what it is we're working with. But what I and we will focus on um, understanding them from their standpoint, but also understanding how humans are, how we use our eyes, how dogs use their eyes, what their capabilities are, what our capabilities are, and then the morphology of why we use our eyes, why we developed eyes in the way that we have, and why dogs have developed eyes the way they have. And then we go into the brain itself and how that layers itself to make sense to the brain. Because that's really, again, I reiterate every time in every class, what we are working with is a brain in another animal. And we're working with our own brain all the time, hopefully. Um, so you should be cognizant of what's going on in your head that influences the dog one way or the other. And stop seeing the outside and start looking into what that dog is communicating, not after the fact, but by its pauses, by the way it behaves as to what signals it's getting and what signals it's giving. And so one of those elements is about the eyes. We have, as far as senses go, for humans, it's eyes, ears, nose, and of course we have touch and feel. Touch and feel is as important almost to us as the eyes. That is not quite the same with dogs. So I want to describe the eyes from a couple of things. I'm going to share screen here and go to uh, a few aspects here, and we're going to look at um, from the. Sorry, I'm going to move some stuff out of the way there.
And Nelson, for contrast, so humans, eyes, ears, nose, dogs, nose, eyes, ears, correct?
We're going to talk about that.
Yeah, I just wanted to
Okay.
have the
Not,
contrast together side by
yeah,
side. So
not
thank
quite,
you.
not quite, but yeah, almost. Okay, so this is from the uh, quit. That is not what I wanted to do. Not at all. Okay, I have no idea what happened there. I think it just changed everything. Let's go back a few times here. Okay, there we go. Sorry about that, guys. There we go. Jeez. I got to use the pen. The finger doesn't work right because of the heat from the finger on this touch screen. I don't know. It's heat sensitive. Okay, so a description of a dog's eye, and a human eye is virtually identical, at least in basic structure. And some of you who've had course one have seen this before and understand, we've got cornea, the iris, the lens itself is the main element of structure where light comes through, and then it is distributed through the lens, depending on the distance it is away and the focus of the lens itself being stretched or allowed to relax to a different shape. Then it focuses it on the retina, and the retina itself, actually, that's not the exact thing. I'll go through my notes here in a little bit. And at the back of the retina is where the light sensors are that we'll go into here momentarily. This is another illustration of the eye, and again, structurally, it's almost identical to ours in every way, including the lid. The only difference is, as you see the cross section here with the lens, you've got a thin sheet. It's almost like a real thin, you could define it as cellophane, um, over the back of the retina inside the vitreous chamber, which is called the tapetum. And that tapetum is a light reflecting, a light protective sheet that is in dogs and a lot of animals, frankly. It is what, when you shine a light in their eyes in the dark or at night, it's what glows back at you. So it reflects a lot of light, and that protects them in bright sun too. So they can look at brighter light than we can and not harm their eyes. So they're well adapted for a number of different, and part of that, also considering where dogs originally came from, which was what is now Siberia, northern Spitz breeds, basically, is where all the start happened. And obviously, if you're looking out in for the next 200,000 square miles and it's all ice and white, you have to have something to protect your eyes. So we use different things over thousands of years to either slits and whalebone to protect our eyes, or we use sunglasses now of some sort, or some screening device. So also the eye itself, if you look at where the blood vessels of the retina are, and that central core of what is essentially a nerve bundle coming out through, it's actually off center of the eye, because if it was centered, there's actually a black spot where there are no vision receptors at that point. And that point being off center means we can actually see everything in detail in the center of our eye, which is a good thing because that's where most of it's focused at. That's our direct vision. The same thing for all animals, where that offset black spot is actually filled in because it's out of the direct vision and focal area of detail in our eye. Our brain actually fills that gap in so that we don't see black spots. So our brain just inherently fills it in and says, okay, that area kind of looks like this, so I'm just going to fill it in as information there. Part of it is not even because we have two eyes. If you had only one eye, your brain would still fill in that area. So these are some technical aspects I wanted to go over. And those vision receptors are actually light receptors, and they're called rods and cones for a reason, because they're actually shaped like a rod, long and thin, and cones are a kind of a cone shape at the head towards the lens itself, and the optic nerve itself. That's showing, this is a basic illustration. They're showing it coming in exactly in the center. It does not, and as a matter of fact, it's outside of the main body of the cones. And there's your shapes and depths. Now, these nerves, the way they are shown in this illustration, they go from one to another with what looks like dendrites in the brain. That's because we've categorized these cells, the specifics of rods and cones, uh, not as some separate body, but actually as brain cells. So the brain is actually extended through time, makes perfect sense. So our survival, our survival aspect is so that um, everything, every sense that we possibly can have goes directly into the brain or is part of the brain, so that translation and time doesn't occur, where because it takes time to go across these gaps between nerve cells from one to another, the speed of that through the body is about 200 miles an hour, not at the speed of light. So the closer a sensory organ is to the brain, and if you notice, almost all animals, at least mammals, the eyes are directly uh, adjacent to and essentially at the front of the brain, and your nose is too, and your hearing is there. So all of those three items, at least in mammals and most animals, are immediately adjacent to the brain, because those are the sensory organs that keep us alive, that let us know what is going on. Same thing with your mouth and taste buds and those sorts of things, so that you know immediately if something's bad or not, and it doesn't take the time. So timing is everything, and the way that life is things go fast when you're trying to live. So those are the aspects. Now let's go into the color ranges of what's going on here, and then I'll go through my notes and explain a little bit more of the technical aspect of this. This is this is based upon, and you guys have seen this before probably, either in course one or on your own study. So human view, the wavelength in nanoseconds, we go from about 360, 370 nanometers up to about 720 nanometers. And within that range of view, uh, within the human's comprehension of what we call light and color, this is the only area that we can detect with our particular eyeball and our sensory organs. This is the same view of nanometers, at least, in the dog's view. Now, dogs do have wider range of detection in light in these wavelengths, but we'll go over that. And so it's a similar aspect from kind of a blue violet into a yellowish area, and then more of a brownish gray. It goes into kind of a gray form. So, comparatively, what your dog sees in those balls isn't exactly right, because they're also looking at other light wavelengths that are prevalent for them, and they have capabilities that we don't. So that's yeah, let's stop share there. Okay, and I'm going to look for a couple of other things here. Let's see. Okay. So I'm going to share this. I'll move this
Melson, you're muted.
How did that happen?
I don't know, but
Okay. Well,
yeah, I
don't do it
cannot.
again. Oh, okay. I don't know what you heard or didn't hear.
Just now we are hearing you. You need to repeat what you've said about the picture we see.
Yeah, we didn't hear you once you switched to this slide. Thank you, Rachel, for pointing that out, Dan.
Oh, well, okay. Well, okay. So in the upper left-hand corner, you didn't hear any of that, huh? About the dog versus human vision. So
Correct.
okay, so in the upper left-hand corner is a selected photo by someone that wanted to show that the red yellows that we see fade out and don't exist in dogs. So they can't pick up red at all. And there's a reason for it that I'll get into in a minute, a little more technically. And then why it matters. And you see, we see into, purples and greens and things like that, where dog's vision is mainly blue and yellow, and then it turns to brown gray, right? So that's the difference you're seeing here. And I believe they selected that particular photo because of the particular colors in it to show what it looks like to a dog generally. That's not exactly true, because if you look at the upper right, you will also see that the dog can see much further into ultraviolet light, about 61% of ultraviolet light range, which we don't at all. We have to have instruments that detect ultraviolet or infrared light and translate that for us in a way that we can see in our nano vision range. So we really don't know what ultraviolet looks like. We translate it as more blue and ultra red, then we would say it's even more red, but or ultra, yeah, infrared, sorry. And so we don't know what it looks like because we can't see that. We can't detect it. So our color receptors aren't able to do that. All right, let me see now. Nope, that's not what I want. That is not what I want either. So I'm going to stop share there. Go back to this. And let's see, for some reason. All right. Oh, I see a few more people joined us. Okay. Thank you for joining us. Sorry for the delay on for a few weeks of conducting this month. Okay, so let's get more into the technical aspect. So the reason that we see the color ranges that we do is we have long wave. Our cones are what pick up color. Okay, that's what we translate in color, and that's basically from long to shorter wavelengths. The long wavelengths would be infrared or red colorations. And then you get medium range, and that gets into yellows to greens between red and blue. Okay. And so then you've got the short wavelength cones, which are shorter wavelength, obviously light, which is the blue, and then going into purples and what we would call violets. And so dogs have only have two color receptors, two capabilities of the detection of wavelengths, and they reside more in the we'll say in the middle between long wavelength and medium wavelength cones of humans. So they see kind of a yellowish, brownish, not red because they can't see red. So it's more of a diffuse yellow, we'll say. And then they've got short wave length cones, which are pretty close to ours in that, but again, a little more diffuse. They don't see the intensity of colors that we do. But once again, in those short wavelength cones, they're capable of seeing up to 61% of the wavelengths, the short wavelengths of ultraviolet light. Now that's served them very well for a number of reasons. And that's what we'll talk about in a moment here. By the way, I'm going to keep this one fairly short tonight because I could talk forever, but I don't want to sound like a college professor talking about science all the time. And I want to focus on another area. So, so what we call vivid technicolor, other animals are able to see other colors that we don't as well, beyond our vision and in more intensity, frankly. So, yeah, I'm looking through my notes to see. Well, okay, I'm just going to talk to you guys instead of going through notes. What I will say is that rods and cones. Okay, so we've been talking about cones mainly in detection of light, and that's the color range. Now, cones are less sensitive to light than are the rods, and the rods are the black and white. So black, grays, all to white, which we see literally as all colors, so a white, and that's how we interpret what we see. Now, if you dial down the amount of light to a very low level, the cones themselves stop detecting light. They're not as sensitive, so they actually go blank in their capability of detecting anything. So a lower light level, then our rods are the only thing still seeing. The density of the rods in our eyes versus dog's eyes, they have more density and more further spread out than we do, spread as far as range. Also in the center of our eye, our critical vision, where they have their cones, we have our cones, and that's where they're mainly focused on is in the center of your eye because they're used for direct vision. And so all those cones that we have packed in there make it difficult for the rods to be in there at the density that dogs have. So their critical vision at low light conditions is much better than ours, essentially about 4 times better, approximately. And so that means they can still see in dark. I'll give you an example. I have black Kong balls and different things that I use with Toffee, and she wants to go out at night when it's dark out and play in the blackness of night with a black ball. And I can throw it or kick it, and she can follow it quite well. I can't see it, but I know she's going after it. She knows where it is, and she grabs it and comes back to me. So we play even at night. And the difference of how they use their eyes for that is, and why it developed the way they did, was because they don't use their eyes. The vision is, ours is 20/20, theirs is 20/80. So in other words, something we see at 80 feet, that level of detail, at 80 feet, they see that at 20 feet. So in other words, we had something at 80 feet and we were able to see the clarity of that. That's the clarity that only they can see at 20 feet. So our vision, our direct vision and our detail is very crisp compared to theirs. Theirs is a little, I'm not going to call it blurry or fuzzy, but it's not nearly as critical as ours. Now, why is that important? Well, because of, once again, going back to our morphology, and that's what you've got to understand, dogs were more successful in low light conditions. They were nocturnal hunters. Doesn't mean that they don't hunt during the day, but it's easier to hunt something that doesn't see you at night. And if you see better at night, well, then you have an advantage. And so one of the reasons that I feed my dogs twice a day, uh, well, there's two huge reasons, but there's many other reasons. And one of them is that I feed them twice a day at basically dusk and dawn or around those times. It's not guaranteed because hunting isn't guaranteed. So we go out and do the hunt within probably 2 hours of dusk dawn either way. Sometimes it is nighttime before or after, and sometimes it's still daylight. So it replicates their natural abilities to hunt during day or nighttime. Percentage wise, during that, if you looked at the broadness of day and night and that dusk to dawn period of lower light levels, percentage wise, uh, canine predators were more successful during that time than they were percentage wise during daytime or full nighttime. And you say, well, why? Because, if an animal's asleep, well, if an animal is not moving, it's tough to see them. So their eyes were developed and needed to be developed for survival, as ours were. And their survival was based upon identifying a profile shape, okay, so that they could actually identify that it's an animal. And they understand animal shapes even if they've never seen that species of animal before. If I took my dogs to Africa and they saw a still elephant, they would know it's an animal before it ever moved. And that's been proven over and over again. With a concrete elephant in a parking lot that my dogs discovered and started woofing at. Didn't move, but they knew it was an animal shape. And so that's the sort of thing that, it reinforces itself over time. So the reason that dogs use their eyes for what they do is, one, they don't have critical detail vision. They never needed it. They don't need to read fine print. They don't need to manipulate stuff to a fine level of detail as a tool. Why? Because their tool is their mouth. Um, and ours is our hands. So, dogs basically were in environments that, first of all, they didn't need to stand up on their hind legs. They could jump up on something and see further temporarily. Having been in, I'll say, doing jobs where I didn't want to be seen in various environments, you don't want to be seen as a predator or you become known or prey. And that's exactly how dogs are and think. So that's why they go around perimeters. They stay close to walls and tree lines and things like that. Coyote packs move in creek beds and stuff like that. So they're not seen by anybody, not just by us, but by any of their prey too. So they were looking for points just like a human would hunting something, to stay hidden as well as be able to see profile, the shape of some animal, and movement. So their eyes are a product of who and what they are, where they came from, how long ago, all of those things. And all of the canid line, bear line, cat line, civets, raccoons, all of those are good at those types of hunting environments. So their eyes are a support mechanism. They are not their main focus. And then we get into the morphology of us versus the dog. Why is that important? Because it changes literally our brains. So dogs were down low to the ground. We stood up. And when we stood up millions of years ago, it looks like maybe 7, 8 million years ago, our ancestors, we were capable of moving and staying upright and seeing over the tall grasses or through them at distances. So our critical vision became important to see distance, coloration, which allowed us to determine not just that it was an animal, what kind of animal was it? Was it threatening to us? Was it prey? How fast was it? Those are all the things that we had to determine quickly when to stay alive. The other part of that then was as we developed the need and capabilities for shaping the environment in many ways, and one of the first ones was to create tools for ourselves because we don't have big fangs. We're not that fast comparatively. We don't have huge claws. We're not that strong or fast compared to a lot of the big predators. Excuse me. So our brains were our advantage, and our brains developed so that we could take something, shape it into a useful element that would multiply our effectiveness at staying alive. That's what tools are. And we were able to do that because we came down out of the trees and stood up on our hind legs, and we could use our front legs on our front paws for something different, which is the entire time of being able to take care, carry, handle things, manipulate, and form things with our hands. Dogs don't have that, obviously. And having that ability, then our eyes became the dominant sense for us to encounter the world, the entire environment. We don't use our mouth to grab and bite something on the run or attack it to defend ourselves or to take something out. That's not what our mouths are used for. We do eat through them, obviously, but we've already captured that or um, incapacitated that animal to the point where we can eat it without getting our faces torn up or bitten a lot. So, and remember where we come from, there weren't many doctors or hospitals or emergency clinics out there. So if you got torn up, there's a pretty good chance if it was bad enough, you would just die. And that's what happened a lot. Matter of fact, only in modern times have we had a situation from about 2,000 years ago, which isn't that long back, for hundreds of thousands of years, 60% of humans died a violent death from something, either a predator or ourselves. So that was our lot in life, and that's why there were that many humans on Earth for hundreds of thousands of years. So the reason that's important is to understand is because now dogs don't have front paws that they manipulate the environment and create tools. What they do have is they've got eyes to be able to see and identify profile shape, an animal or inanimate object, something that's dangerous, something's coming at them, whatever else, that movement and their critical nature of, again, eyes, ears, mouth, nose are all immediately adjacent to our brains. So we have very little time to be able to get the signal, process it, understand it, and take action. So in our abilities to do things, our eyes became dominant because it kept us safe. We could see further. We could also see critical vision. We could identify numerous things because we ate more than just an animal. We also ate plants, we ate grains, we ate nuts, we ate just about anything we could to stay alive. So we had to identify these things in critical details, including colors and patches and et cetera, et cetera. So when you look at it from that standpoint, being able to understand how we developed as a species and how we survived, it makes sense how we think. Dogs, their eyes are subdominant. So when we look at this, the difference between us and dogs, and this is where we start getting into why is this important to even know about. It isn't about throwing a red ball in green grass and the dog not seeing it if it's not moving because they can't see green or red. It looks the same to them. It's ridiculous that we have red balls that we throw into green grasses. So to us, the world is, and all of our languages reflect that we use our eyes as the dominant thing for our survival. Therefore, our brains are structured to count on, first and foremost, our eyes. When someone is blind, a human is blind, we feel sorry for them that whatever has taken away their primary, most dominant aspect to survival. Now, they have other senses, they get along, they learn how to read Braille through touch, okay? And this is the key, is our eyes are our focus. That is the brain's focus. It's how we are dominant in the way our brain thinks. It's the way we are dominant in the way our brain is structured. We use words like see here when we mean to think or pay attention. Hey, look at this, or look at my way. All of the things in our speech and our languages worldwide are about our eyes. That's how we think, literally, is through our eyes. Our hands, our feel, our touch, that is the subdominant aspect of how we think. So when we see something, we don't grab it with our mouth, we don't listen for it, we grab it with our hands. So it's 1, 2, dominant, subdominant. And that's how we think. Our brain is literally structured that way. If you were hearing dominant, you wouldn't use your eyes in the same way. So stating that humans are our brain, which is everything we think, everything that we do, all of those things that we comprehend, and how we relate to others. Okay, because you're working from your brain to another brain, whether it's a human, a dog, I don't care what it is. You're using your brain to try to communicate and whatever, manipulate, not manipulate, relate to, whatever. Okay, so your brain is in the mode of what do I see and how can I touch, feel, handle it? What is it? And this is what corroborates to your eyes to the brain. Hearing is a minor element. Our nose has become extremely minor. And what something tastes like is, you don't put your cat in your mouth. Okay, so that's not how you experience things. So that is the least dominant aspect of how we identify and use things other than for food. Okay. Now dogs, on the other hand, dogs use their nose, and their nose is the dominant, and their tool, the subdominant, is their mouth. So we are virtually in almost every way, shape, and form the exact opposite of the way dogs think. Where eyes, hands, they are nose, mouth. This is where a lot of gaps happen in understanding and training and clients understanding their dogs, how we treat them, et cetera, et cetera. And I cannot emphasize this enough. A dog uses this nose to identify what it is, who you are, what you ate that morning, what your clothing is. You know, Bosch comes every morning. I get dressed. Once I puts my pants on, he comes by, he sniffs my knee and pants to see, what do I smell like today? Who am I today? And then he stops and he stretches in front of me so I can sniff him so he can tell me who he is today. And that's our morning routine every time. He needs to know who I am, what I smell like, what's my health today based upon what he smells on my pants, because that's what he's got to take stock of as my service animal to take care of me. So he's going to identify me each day by what I'm wearing too, and how that interacts with what I smell like underneath and my breath and all the other things that dogs smell. You know, I have explained, I'm not going into the nose itself, but it is such an incredible and amazing detection device. We almost can't fathom what that is, but they're capable of detecting just one particle in 10 quadrillion, which is 10 with 15 zeros behind it. Write that out sometimes for yourself. One particle out of 10 quadrillion. That's just visually looking at is an absolutely amazing number. And they can detect all the other 10 quadrillion in there too. So when they walk in a room, they smell everything in it, everything, absolutely everything. It's just identifying exactly where it is and in more detail when they go up to sniff something. When they smell something, you know, in the air, for instance, you know, every once in a while we get huge weather patterns where the dust from the Sahara Desert in Africa comes 6,000 miles and comes in here to the United States and up into Canada. The dogs smell that. They smell everything that has been blown over. And, you know, we just see a dusty sky. So that is their main sense. And so their brain is structured. I want you to understand their brain is structured based upon scent. In other words, the nose detection and the mouth of how it manipulates and how that relates to those things. Eyes are a much more subdominant. It is just to identify movement, shape, etc. And it's also a detection device for, because of infrared and other areas, how they see us. They see us entirely different than we see each other, literally. You know, we see ourselves as this shape and color and stuff. And they're actually looking, because of their sight capabilities, they're looking through our clothing into our body and detecting areas that you know, I had an ulcer years ago in my stomach, and a dog I didn't know came up to me. I sat down, it came up to me, it stuck its nose in my jacket, pushed it apart, and stuck its nose right on my ulcer and sniffed it. How did it know that from 30 feet away? Because it saw it through my clothing. And then it corroborated, yep, that's where it is, and that's what's wrong with you. So that's the capabilities. That's why they're detecting cancer in them is child's play. They smell everything. So when we work with a dog and we're working with, I see something, blood pressure is high. Yes, they can also hear your heartbeat. Their hearing is 4 times more critical than ours. So they can, in a quiet area, they can hear your heartbeat, the rate of it, the pressure of it, all of those things. So they corroborate with the nose as well. So, and the eyes. So their senses, the reason we have service animals, the reason we survived better on Earth with them the past 41,000 years is because of their capabilities versus ours. And they survived because of our capabilities versus them. We are a co-species. I can't say that enough, guys. we wouldn't exist this way without them. We'd still be, running around as hunter-gatherers, maybe 2 million of us on Earth instead of 8 billion. So why do we care about this? Well, first of all, is to have respect for that animal. Its capabilities, its understanding is much different than ours and much more capable in many areas. You are not the superior being that you think you are. So take your ego, stuff it in your pocket, and sit on it. You should look at that animal with respect and treat it with respect and understand that you're not mommy and daddy. You're not, that's not a child. That's an amazing entity that is worthy of, first of all, your respect, trust, and caring. And they will do so in return in spades, so to speak. So, so the talk tonight really is about you understanding, not just you, I'm sorry, humans understanding that dogs have different senses, sensibilities, capabilities. And the reason they do is because of survival. Goes every question everybody has ever asked me goes back to the point of survival. So the way we survive because of our morphology, our capabilities, the way our body is, the way our brain is, the way our capabilities of senses are, that we have sweat glands, they don't, all those sorts of things. We have certain aspects. They have different aspects. So therefore, our brain is structured around what we are. Their brain is structured around what they are. They are not human. They don't think like us in any way, shape, or form. They cooperate and collaborate with us to survive better, just like we used to. Now we just have dogs because we want them, because we want that with the picket fence. So make sure that you are really, truly understanding. I'm not even going to say look at dogs because that's what everybody does. They look at the outside. Every place I go with Bosch, I went to lunch today at a restaurant that I always go to. Bosch is off leash with me. That's how he does his job best. We walk in, everybody says hi. I point to a booth. Bosch goes, tucks himself underneath, gets out of the way. Have lunch, and two ladies that were sitting in the next booth as they got up to leave, what I hear 1,000 times a day: your dog is beautiful. My answer is yes, he's very smart. I've tried to change people's minds about what's inside, not what's on the outside, because what's inside is more amazing than what they look like, guys. And they think differently. Their brain is literally structured differently. Yes, they have the same parts generally in the same order that we do. They have the same neurotransmitters and hormones that we do, identical. So we can have some understanding of each other. That's the whole point. But how they use that information is entirely structured different. So if you don't respect that they are a nose machine with 4 legs and a mouth versus us, an eye machine with hands that manipulate, and we think differently because we do manipulate. Dogs don't manipulate. They either cooperate or they're in conflict. And that's why I teach cooperation, not conflict. So we have to think differently to really reach dogs correctly. And that's the whole point of this talk tonight. And I hope it makes sense to you guys. I'm emphasizing it because I was able to get the chance to do so in that form. So a few questions. Yes, Angela. I see things popping up. I can't see it at the bottom. So
Yeah, I will, so I had a quick question. Did you state that dogs have more rods in their eyes than us humans do? Is that, or did I misunderstand incorrectly?
density wise, that is correct.
Okay, thank you.
And especially in the center section. Our night vision isn't very good comparatively. I have very good night vision for a human, but it pales in comparison to a dog.
Okay. Thank you.
Yep.
Okay. That was a quick, easy question. So we have a couple of questions in the chat. What is happening in a dog's brain when they switch from nose/eyes to only eyes and reacting to what they see?
Okay.
And what circumstances are influencing this switch?
Okay. So that's an extra, boy, is that a critical question. Thank,
Rachel.
yeah. And that's a whole talk on its own, frankly, is that switch between nose and eyes. You know, what I used to tell all of my clients, I think all of my clients, Carol, if she remembers that back when she was a client of mine, over a decade ago, um, the quick description for people is a dog using its eyes as a predator. The dog using its nose is a curious animal. It's a dog. Okay. And so that's the very simplistic, how humans want to push a button and they want an answer. That's the quick, easy answer to keep people safer. So a dog using its eyes is trying to determine the part of the language that is not about scent. It's all about the communication of distance, speed, movement, tenseness versus relaxation, all of those aspects. And whether something is injured or not, infirmed or not, all of those things through movement, that you may get some of that from hearing something critically or smelling something, but not very much of it. So that's the corroborative part of the eyes. So something is either off in understanding, critical in understanding for the dog, or they're shifting from, I know what you are, but why are you doing that? And so I'm going into a predatory mind state. There's about 1,000 answers. Like I said, this could be an hour and a half. It could probably be a whole course on its own of shift between eyes and nose, because that's really understanding a dog inside its brain. That is hypercritical to understand. And when I talk about timing, timing isn't catching that dog before it does something, because if you're looking at the outside and not the brain, you're behind, because it's already made up its mind by the time it does something physically. So timing isn't about catching it early physically. Timing is about understanding what's going on in the brain by its actions before it makes the decision to move or do anything else. And that quick switch from the sniffing to eyes, you better catch it then. You better understand what's going on. And if it's not your dog, you need to send the right signal instantly that I'm not interested in you, I'm not a threat. Okay. And vice versa. Once it satisfies itself, satiates itself with you're not a threat, then it goes back to that relaxed state in the eyes, and it goes back to counting on nose, hearing, et cetera, et cetera. Okay. Does that make sense?
Absolutely. So I'm having this epiphany moment that
Did it hurt? Oh, I'm sorry.
no, it felt great. Well, only because this totally explains why you go into such depth about eyes, ears, nose, structure, biology, psychology, all of these things. Because if we have that better understanding of the dog, then we can be one step ahead of that brain because we're thinking like them
Yes.
and we can address or
Understand.
guide, teach, lead appropriately in the moment.
Yes. Not afterwards, not have to counter and pull the dog back to a different state of mind when it's already decided something. So you're in conflict with the dog. You want the dog to agree. So how do you get a dog to agree? You present yourself in the right way in that timing, in that right moment, to understanding what they're about to go into, because you understand the senses, the capabilities, the way they think. It's the whole package, guys, every bit of it.
I've just heard you say this for years and it just, yeah, it all just, you're never too old to
Yeah, Angela,
keep learning.
don't feel bad because
Oh, I don't. I
I-
love it.
I remember him
it's
saying it,
humbling.
but I didn't know what that meant. And
Hmm.
even with this talk, it's like, oh, yeah, okay, all right, let me put these pieces together again. It's making sense. So yeah, it's time and repetition.
Yep.
And all we're talking about is one little tiny thing, the eyes. There's thousands and thousands of the rest of it, different things, guys.
You already made my brain hurt. And it's only been an hour. You're making my
Success.
brain hurt. Would you stop?
No, I won't ever
No.
till I die. Yeah, that's the point. Okay, any other questions?
Yes, sir. We've got another one.
Okay.
Are there differences between breeds and their capabilities to see at night? For example, are LGDs better to see at night than other dogs?
Good question. The answer is yes, depending on what that animal was bred for, the specific genetics that it was used for. Sight hounds versus rat terriers, for instance, they're different. So sight hounds, literally their distance vision is so important, and being able to run down something, for instance, a pharaoh hound in the desert. We were talking about that in this last class of having different dolichocephalic, very long muzzles, because it's easier to grab something on the run that's doing 50 miles an hour and you're running it down and you're running at 35 miles an hour. You're not going to knock down something small, you're going to grab it as it's running. So but you've got to see it at distance, you got to see that movement. And different breeds of dogs were bred or natural for different environments. A Siberian Husky, their contrast, their capabilities, for instance, they've got to be able to see from dark boreal forests into the most blinding bright, just pure white landscape and see detailed differences in there that would blind us. So they've got quite a bit of capabilities that we don't have in their eyes. And also seeing into ultraviolet range, they also see pockets within the ice and the snow, which helps them initiate a contact with some animal underneath, a seal or something else within those areas, and able to then check it out with their nose and get downwind and be able to attack and get food. So just as an example, but yes, there are differences in the breeds. Not huge differences, because they still have those capabilities, but their eyes are generally about the same. Remember that most of the breeds that we have now that we recognize as separate breeds are just created in the past 200 years. So the genetics of those happen to be with the specific reason that we were breeding that dog to be smaller, larger, faster, whatever the capabilities, more obedient, we'll call it, or general purpose. A German Shepherd was created basically as a general purpose dog. It could be herding, hunting, it can be protective, it can be, working military, police, it can be lots of things. Why? Because of its understanding of the loyalty to that human or humans, that grouping, and it's able to accept those things. So that's, anyway, I could go off on things for hours, sorry.
No, all good. Another question, are the eyes of brachiocephalic dogs compromised besides being more prone for injuries as the eyes are standing out of the head?
Well, I'll put it this way. So what we have done to dogs like that, creating those dogs which can't create themselves because they would all die in birth in the first place, we've done a great disservice to them. Yeah, a lot of those types of dogs, obviously they have eye problems because they're bulging. There's, we've created bottlenecks in genetics and bad genetics to where, glaucomas and all sorts of things that happen in different breeds. They're more prone to those than we'll say the more natural breeds. But even those, and I guess I say a few controversial things. They're controversial because they're not the same thought as the general public these days, which is, uh, I am not for early spay and neuter because we're taking the good genetics out too. We're destroying dogs with that mindset. We're literally going to destroy dogs over the next 100 years if we keep this up. They're going to be a hot mess, all of them. There won't be any good dogs left. So, any other questions?
Yes.
Okay.
It's interesting with what you just said because someone we just interviewed for a Dog's Eye View podcast said in the next 10 years that we're going to
Well,
destroy
I'm
dogs.
I'm giving us a little bit of time and grace, but we're doing it very rapidly. The dogs 50 years ago were vastly different than the dogs now and less problematic.
Yeah, it's kind of scary.
Well, it's sad. Once
well,
again, we
absolutely.
get in something, mess with it in a human way and screw it up.
Yep.
That's us.
Yay, us.
Yeah.
Yes. So another question: if a dog's vision is fading away, what are the first signs of them going blind? So I would say, I guess, physical or behaviors or actions that they might do that would help us to
Well,
understand that.
yeah. I mean, there's different types of blindness. Obviously glaucoma pressures that cause pains, change vision. There's cloudiness in the iris itself, which and the lens, I should say, which actually one of the reasons I use food grade diatomaceous earth once a quarter is to make sure that those minerals that adult bodies need, including humans, get or have the chance to be absorbed by the body. And so those minerals are critical in clarity of vision to actually clear up the lenses. And I've recommended that a few times, that over many years, that trainers have said, I've got a dog, it's getting cloudy eyes. And I said, use DE for 10 days. And guess what? They clear up. And I'm not a vet. I'm not a doctor. That's not medical advice. It's just what happens. And if you look at the minerals and substances, what make up DE, it's something that depletes out of adult bodies and in dogs fairly quickly, actually. So I use that, and all my dogs have always had clear eyes. I've never had cloudy eyes. So that's one area of vision that you can help. There's other, obviously, the nutrition itself that helps vision, support vision, and the every aspect, the organ cell, actually body itself, as well as the brain cells in the back of the eye. But yeah, it's I would say genetics, nutrition are the two main things, and we keep screwing things up. We're going to make deaf, dumb, and blind dogs, so to speak. I don't know if I answered that question right. I forgot what it was. Sorry.
Signs that if a dog is going blind, things to look out for.
Well, obviously, its behavior is going to be there. There's a couple of things. One main thing is uh, it's sudden startling. If it can't see, for instance, peripheral vision uh, starts becoming less. in its range of understanding. Secondly is that, and you can check peripheral vision by moving your fingers or something to the side, much like you would do snap of, behind the ears. You can check peripheral, overhead, underneath very easily. And if you see a deterioration of that, then obviously that's one of the signals that's startling, of all of a sudden just seeing something. The other is the guardedness of the dog. All of a sudden it changes, and there could be a number of reasons for that change. They do that in age. They do that when they feel infirmed or they start to feel weakened. Is that preemptive strike attitude, where a dog may, if they're startled, or if you see them pause there and then suddenly react, something's going on. That could be thousands of things, but it's certainly one of the things that is an indicator with the eyes too. Any of their senses, if they are dulled, a predator knows that it becomes weaker, and weakness gets attacked and eliminated in nature. So it's trying to preemptively act to not get eliminated, because life wants to live. All life wants to continue living. So those are two areas that are main areas. There's others, obviously, walking into something. Now that could be a brain or a mental thing, or an Alzheimer's type of deterioration of the brain, or a brain tumor or something like that, if they just walk into something. Bella, at her 22-year age right now, her eyes are very, very poor. They are cloudy, and even though I use DE, it's glaucoma and other elements that are in her. And of course, at her age and capabilities, well, like I say, who knows, she may outlive me. She's already surprised me by many, many years, by probably 8 to 12 years. But she's just got the drive and desire to continue living. I just love it. But being the oldest husky on earth, literally, she's amazing, but she doesn't have much in the way of eyesight anymore. But she still gets around. She gets into corners and gets stuck, and then realizes she's stuck and has to turn, when it's all kind of the sameness of density of look and light and all that stuff. When there's no contrast, she kind of gets befuddled, I'll put it that way. So those types of times too. So when there isn't a lot of contrast, you'll see a dog, in light amount, you'll see a dog that has diminished vision, having problems with kind of bumping into things, or listening for the sound of their own footsteps and where it bounces off of something, and in reverb. So that's a few things.
Nice. Thank you.
Yeah.
And that was it.
Is that all? Okay.
That is all.
Well, it wasn't a short session, so I'm glad. I hope you guys learned something. I thought about how to do this. I didn't have a list of anything like, or an outline. I knew I wanted to go into those 4 areas, the aspect of technicality of what is an eye, how's theirs is structured versus us, what it means to them. In other words, the morphology of why it is the way it is between us and them, and then that breakdown of understanding between how we think and how they think. And that is because our eyes are everything. Their eyes are a supplemental. Okay. All right. Thank you, guys. I really appreciate you. I really do. Thank you.
Thank you, Nelson.
All right. Good night.
Good night.